this last one here, we're being asked to solve for n. So we know that the sum of all these terms equals 63.5, and we're adding terms from 1 to n. So we don't know exactly how many terms. So how are we going to do this? Well, this one is probably easy enough to guess and test because this sigma notation allows us to generate each term. So I'm going to put this in and say 32 1/2 to the power 1 minus 1 is 0. So the first term is 32 plus, I'm going to add, so this is T1. I'm going to add the next term. So I'm going to need to figure out the next term. If I plug in 2, I'm going to end up with 16. This is T2. So at this point, I can just keep track of my sum. This is equal to 48. Plus, I'm going to have to go bigger. The next term, I plug in 3. It's going to be 1/2 times 1/2 times 32. This is actually a geometric series going down by 1/2, a factor of 1/2. So 48, 56, 60, plus, that becomes 62. Wow, this is getting hard. T5 plus, but we can just keep on going and just count. This is probably the most reliable way to do things, is by counting. So let's see what we have so far. 32, 16 is 48, 56, 60, 62, 63. So I'm at T6, I'm at 63, and the last term is going to be 0.5, so that's our T7. For solving for n, we can just list this out, and we can get n equals 7. Okay, and this is a reliable way to do this. Now, as n gets big, this might be a little bit difficult. The only other way we could do this is if we have a formula for this sum. And for that, the only formulas we have are for arithmetic series and geometric series. So if we can recognize that this is a geometric series, so I might have done the first couple terms, and recognize that's a geometric series going down by half, well, I can do this using my formula. My Sn is equal to a Rn minus 1 over R minus 1, and I can just plug in the parts I know. I know a is 32, R is times by 1/2, and we're looking for, and we know that Sn is equal to 63.5. So plugging this into the formula, I get 63.5 equals 32 1/2 to the power n minus 1 over 1/2 minus 1, that's negative 1/2. So solving this algebraically, I get 63.5 is equal to, this is going to be negative 64 when I simplify that fraction. Put square brackets around there. Dividing the two, so I end up with 63.5, divided by 64, and that's going to give me 0.992, and I don't want to round this, but and this equals to n minus 1. So if I add 1 to both sides, so that's going to be negative, sorry. If I add 1 to both sides, I'm going to end up with plus. I'm going to end up with 0.00788125. Okay, you may want to keep the fraction in here. And if I convert this to a fraction, I should get a fraction that's divisible by, that is a power of 1/2. Okay, so in this case here, because n is 7, which I kind of knew already, that number, if I convert to a fraction, really is 1/2 to the power 7, and I get this solution here. I could match my exponents and get it n equals 7. So if you know logs, you can apply logs here. Otherwise, we need the fractional value of this to be able to match the bases and solve for n. This problem though, for now, we're probably going to use the strategy of just counting and add until we get to the right sum. And that's going to be a strategy that's good enough for now until we learn some logs.